Right, hello everyone. Welcome back to another video. I hope you're all doing well. In this video, we're going to be talking about buffer solutions, and this is from the HL part of acids and bases, so topic 18. If you're an SL student, you don't necessarily need to know this, but if you are an HL student, these kind of questions do come up both in paper 1 and 2, so it is an important concept to grasp. And I see many students having a problem with this concept, and the main reason why they do have an issue is because they don't really understand what a buffer really is and what is the purpose of this buffer, right? So I want to start off with what exactly a buffer is. So a buffer solution is a solution which resists a change in pH when you add small amounts of acids or alkali. So a buffer, oops, a buffer resists changes in pH. So if you have a solution and you want to ensure that the pH of that solution doesn't change by much, you add a buffer to it, really. That's really the simple use of a buffer, right? That's what it does. It resists a change in pH. But another thing that's important to remember is that it resists a change in pH when small, the keyword being small, amounts of acids or alkali are added to it. So really, if you think about a buffer solution, right? If you think about a buffer solution, you add it to something, you add a buffer solution, and the solution of the pH, for example, is 4. And then to this solution, if this is the pH scale, the buffer is going to try to keep the pH of the solution at this initial starting point. It may let it go a bit to the left or to the right. So it may let it become maybe 3.9 or 4.1. But it's going to do its best to resist the change in pH and going to keep it at pH 4. And this is only when you add small amounts of acids or alkali. If you add too many, or if you add too much acid or too much alkali, the buffer is going to run out and it's going to um, end up changing the pH of the solution. Okay, now I'm going to show you how a buffer works, what exactly a buffer is made up of, and really how to solve this question above. I actually haven't even talked about the question because before we can even talk about the question, we need to understand what a buffer is. So a buffer, what is a buffer made up of? Okay, so a buffer is made up of two things. A buffer is made up of it can be made up of a weak acid or it can be made up of a weak base. So one of these. Plus, in addition to this, a buffer also has to be made up of a salt of the weak acid. So it should be this and this, or it could be a weak base and a salt of a weak base. So these are the two things, or well, these are the combinations you can have if you want to make a buffer solution. So you can either have a weak acid and a salt of a weak acid, or you can have a weak base and a salt of a weak base. You can't have a weak base and a salt of a weak acid. That doesn't really work. That's not going to give you a buffer solution. Okay, so you need to have these combinations, and this is what's going to give you a buffer solution. Now we know how we can create a weak acid. We just have to get a weak acid, right? You can get a weak acid like ethanoic acid or propanoic acid or something like that. How do you create the salt of a weak acid? Well, the salt is pretty easy to create. You just react the weak acid with a strong base. So you can suppose if you have CH3COH, which is ethanoic acid, you can react it with NaOH, which is a strong base, and you end up getting this, which is a salt, and this is the salt of the weak acid, and of course you get water. So there you have it. And for the base, it works in a similar way. If you have a weak base, let's say something like NH3, you can react it with HCl and you get NH4Cl. So this is your salt. This is a salt of a weak base. So okay, all right. I hope that's made sense. Um, that's how you can create a salt. Now, what is the purpose of the salt? Why do we need the salt in a buffer solution? Right? Why do we need the salt? So if you remember, when a weak acid reacts with a base, it creates a salt, right? And the salt looks something like this. So again, I'm going to use the example of CH3COOH reacting with sodium hydroxide. So the salt we got out of that reaction, if you remember, was this CH3CONA. Now this salt is made up of two parts. This salt is made up of the negative part of the acid and the positive part of the base, right? And this negative part is called the conjugate base. So this is the conjugate base of the weak acid. Now, what we really need for the buffer, the reason we need the salt is not because we want Na plus. We don't really want Na plus. What we really want is the conjugate base and the weak acid. This is what makes up a buffer. Because remember I told you the definition. What does a buffer do? A buffer resists changes in pH when small amounts of acids or alkalis are added. So imagine you have a buffer, and in that buffer you add some alkali. The alkali will go and react with the acid, right? So it'll sort of be mopped up by the acid, and that will prevent a change in pH. Because when an acid and a base react, it's a neutralization reaction, right? So the pH doesn't change. Now imagine if to that buffer I add some if I add some acid, right? Instead of a base, if I add some acid, then that acid will go and react with this conjugate base. Because remember, bases and acids react together and they give a neutralization reaction. So if you add either acids or bases, the buffer can neutralize those acids or bases added, because you have a weak acid and a conjugate base present in your buffer solution. So you need the conjugate base to mop up any acid, and you need your weak acid to mop up any bases which have been added to the buffer solution. I hope that's made sense. Let me just show you what I mean in a more diagrammatic fashion. Let me just sort of delete this. Let me remove all of this. So I know I've sort of dumped a lot of information on you guys, and I hope you've been able to follow through with me. I just want you to take a note of something. If you are not very good with the acids and bases chapter, this video is not going to make a whole lot of sense to you. To really understand buffers, you need to have a strong base in acids, or upon there. You need to have a strong base to understand acids and bases, right? You can't understand buffers if you don't have a strong base in acids and bases. So you need that before you can understand a buffer. So if you do have any questions regarding acids and bases, you should either message me, or you can go and watch one of my previous videos, and I have made quite a few videos on acids and bases, and I hope that they help you out. But anyways, let's move on to my example of a buffer. So again, I told you, let's create a buffer. Okay, let's create a buffer. My buffer is going to be a weak acid buffer. So a weak acid buffer is a buffer where you have a weak acid and the salt of a weak acid. Okay, so for my weak acid buffer, I'm going to use ethanoic acid. I'm going to create my salt. That's the first thing we need. We need a salt. And you create a salt by reacting your weak acid with a base, a strong base. You have your salt. You can take our salt, and our salt comes like this. Yeah. So this is what we want. This is our conjugate base. This is what we want. And then we have our weak acid, of course. Now, how does the conjugate base and the weak acid prevent change in pH? Now, I want you to imagine that we have a solution. This is a buffer solution. This is a CH3COOH buffer solution. So inside this buffer solution, we have two types of molecules. We have the conjugate base of CH3COOH, which is CH3CO minus, and we have the acid itself. So these are the two things that we have inside the buffer solution. Now imagine if in this buffer solution, I add some OH minus, I add some base. What will happen? Remember, the buffer wants to resist change in pH. So what's going to happen if I add this base? Well, the base is going to go and it's going to react with the acid, right? The base is not going to go and react with this base. It's going to go and react with the acid. So it's going to go over here, CH3COO plus OH minus, and you're going to get CH3COO minus plus H2O. So as you can see, the base has been neutralized, right? It's been neutralized. Now imagine if I add some H plus. If I add some H plus to make the solution acidic, the H plus is going to go and is going to react with the base. So what you're going to get is CH3COO minus reacting with the H plus to form CH3COOH. Now, hopefully you can see what's happening over here. In the buffer solution, when the weak acid reacts with the base, it forms the conjugate base. And when the conjugate base reacts with an acid, it forms the weak acid. So it's sort of a cycle, right? It's a regenerating cycle. And this is how a buffer solution manages to resist changes in pH. Because if you look at this equation, if you look at both these equations, sorry, I've made it a bit messy with all these lines. Let me just erase that. If you look at these equations, in all of these cases, either you're neutralizing your added base using your weak acid, or you're neutralizing your added acid using your conjugate base. And this is how we manage to resist changes in pH. So that's pretty much it for buffers, right? You just have to remember, for a buffer, you need two things. You need a weak acid or a weak base, and you need the conjugate acid or base of whatever you're using as a weak acid or base. So if we look at this question, for example, let's get to the question now. Let's put stuff into context of the question. Let me just erase all of this. Now in this question, they've told us, explain using two equations how an equimolar solution of ammonia and ammonium ions act as a buffer solution when small amounts of acid or base are added. Now, ammonia is a weak base. Ammonium ions are the conjugate acid of ammonia, sorry. So ammonium ions are a conjugate acid, and ammonia is a weak base. So we have a weak base and we have the conjugate acid of the weak base, and this gives us our buffer solution. Remember, these are the two ingredients we need to make a buffer solution. Now, how will these two resist pH? We need to write down two equations. And if you sort of remember, I showed you two equations below in how CH3, or the buffer solution of CH3, the buffer solution of ethanoic acid, two equations. I used two equations to show you how they can resist changes in pH. Now I'm going to do the same over here to show you how these can resist the changes in pH. Now, if I add some base, imagine if I add some base to this buffer solution. The base is going to want to react with the acid. So we have NH4 plus OH minus, which is a base. It's going to form NH3 plus H2O. Now imagine if I add some acid. Now this acid will react with the base. So we have NH3. It's going to react with some acid to form NH4 plus. And again, you can see the cycle. When the NH4 is used up, you form the weak base. And when the weak base is being used up, you form the conjugate acid. So I hope you understand how buffers work now and how they are used to resist changes in pH. You can think of it as such, where the conjugate acid mops up the base, that is the extra base that is added, and the weak base mops up the extra acid which is added to the solution. So you need both. You need a weak base and you need a conjugate acid if you want to form a buffer solution. Otherwise, it does not work. You need a weak base and a conjugate acid, or you need a weak acid and the conjugate base. I hope that makes sense. So this is the answer for this question. You just need two equations, and we have two equations over here where we explain how these buffer solutions can resist changes in pH when small amounts of acid or base are added to a solution. So this is our answer. I hope this video has made sense to all of you. Thank you so much for watching. In the next video, I'll actually get on to pH curves, because you need to understand buffers if you want to do pH curves. So we can discuss pH curves in my next video, and hopefully this video has cleared up any doubts you have about buffers and how buffers work, what a buffer is made of, and how to write equations of buffer solutions resisting changes in pH when an acid or base are added. So that's it. Take care of yourselves. I'll see you in the next video with another question, and goodbye.